split into two halves. I'm coming up first, giving a bit of a background and the challenges of performance in the CI process, and then I'll hand over to Mark, who will go through a practical kind of case study of what he's actually been doing in this area of Channel 4. Before we start, I'll just give a quick introduction to Intechnica and who we are. So this is part of our privilege as a sponsor. I get to do a little advert at the start of the process. So we're an all-round performance and development consultancy. So any area related to performance of IT systems, web systems, best practice from the start through the development process, performance testing, performance engineering. So anything to do with performance is something that we will advise and help with. And the reason why we're here tonight, as well as if anyone wants to buy stuff off us, if anyone would like to come and work for us, we are looking for people, performance architects, performance engineers, consultants, anyone who is a developer at the moment who's got a lot of experience in high performance websites or optimizing things for performance, performance testers, experience in performance testing tools. We're looking for those in the London area. In the Manchester area, there's a whole range of things you can see at the bottom that we are looking for. And if anyone's interested in that, you can talk to me, or there's a few other Intechnica people around there, so over there, at the back, one there. So feel free to talk to any of us, or email, go through the website, phone us. If you're a recruitment consultant, please don't phone us, because we will just get hung up on. And it's Tom there who always has to answer the phone, and he does hang up on recruitment consultants. Okay, so on with the actual show. So one of the things I thought I'd start with is, where does performance sit in the development process? So this is something that we work on a lot. Sort of how we try and engage with people who work with us is getting people to actually put performance in its proper place, basically to treat performance as what you might call a first-class citizen in the process. And this somewhat confusing diagram, I think, is trying to show that. So at the bottom, we're trying to illustrate where performance is traditionally put in a development process, which is at the end. So normally, or traditionally, people would develop their application, get it all finished, get it all ready to deploy, and then think, let's performance test it. And at that point, find it was unperformant, and then either put it live anyway and hope for the best, or go back and spend a lot of time and effort trying to fix it. What we're trying to promote is the idea of performance right through the process, so right from specification stage. So when you've got the idea, think about performance of that, architect performance in, build it into the design and test phase, and then obviously verify performance, and then through to the live system, monitor performance and feed that back through to your continuous improvement process. So, got this in what is CI? Before I do this, how many people know what continuous integration is? How many people don't? Is everyone happy to just skip this section? It's fine. So this is a quick background to where the CI process. Who does continuous integration as part of their process here? Sort of. Does anyone do continuous delivery? One brave soul at the back who does it. So I think continuous integration is probably a fairly sort of standard process that people would like to work towards. And I think part of the continuous integration process, to me, is it can be very basic, or it can be very, very comprehensive. And as soon as it's comprehensive, then continuous delivery, continuous deployment becomes an option. Until that point, continuous delivery is too risky for most people to consider. And what we're talking about here is, how do we put performance into a continuous integration process? Because it is as important as automation, integration tests, and all the other tests you do. So before we start, should, or indeed can we even build performance into our CI process? Yes, we can. You definitely should. But this is not the end of the talk. I'm not just going to say that and then leave. We go on a little bit. We should do it. Why should we do it? Why why is performance important enough to be considered? And for me, performance is a first-class citizen. It's as important as functional issues. Performance issues can be more damaging to your site than a functional issue. One performance issue can stop all traffic to your site. A functional issue will generally just affect one particular area. And performance issues are often harder to fix because they will often involve re-architecting the system. There will be fundamentally core problems to the system that you have to go back to the basics to fix. And obviously, the earlier you know about these problems, the better. Finding out on live is not when you want to find out about performance issues, because then you're up all night fixing the performance issues and desperately putting things out the next day and seeing if they work. But, having said that, one thing is, don't be over-ambitious with this. You've got to test a level that is appropriate to where you're up to in the development process. So don't be testing your full performance acceptance tests at the point when it's only half developed, or you're testing on a pre-production system or a development system that's obviously not going to perform. I would say set realistic values as well. It's very easy with performance problems to get false positives. Performance, this is where it gets tricky in the CI process, is that performance is not a binary process. It doesn't tend to be you'll introduce one change and that will introduce the performance problem. It's a linear problem, so it'll build up over time and then there'll be a point that will push it over the edge. So you've got to functional test issues. It's fairly straightforward. When the problem is introduced, you look at that check-in and look what was in that check-in, and that will probably have caused it. With performance issues, the problem could actually have been introduced 3 or 4 check-ins ago, which took your performance from 1 second to 9 seconds, and then subsequent ones have pushed that up over 10 seconds, which is your threshold. But that's not actually your problem. You need to look a bit at the history and look over time to see where the problem came from. Okay, so what types of performance can we look at? The simplest one from a CI point of view is looking at kind of micro benchmarking point of view. So that's looking at very, very small little bits of code, setting KPIs against it, and these can be something as low as an individual unit test or one integration test. But set KPIs against that, basically run acceptance tests against that, and that's fairly straightforward to build into a CI process. You can do that on either not under load or under load. Obviously there's more complexity to building load. Things to consider about that, obviously your size of your data set makes a massive difference for performance. Most performance problems in my experience are database related, data set size related. Your environment's obviously key to that. You can't test at your expected performance levels on live if you're testing on a small development server. And obviously any third-party integrations which can have a major effect on performance, but you may or may not want, Mark and I were having this conversation on the way here about whether you would exclude your third-party integrations from your performance test or not. Another type of test which I think is very, very interesting from a performance CI is just to do client-side tests. So look at things like the page weight, page load time using something like web page test. And then obviously the kind of full one is your full test under load in a realistic environment, realistic data sets. So basically you are doing a full performance test of what will be the same on live, and you can set your actual live performance KPIs against that. Okay, so how does performance fit into the CI? So, like everything with CI, you're looking at shortening your feedback loop. So this is kind of typically the first half of a typical CI process, so it's across 2 slides because it's too big. Any CI process, you'll probably look at doing your simple, syntax, dependency, build, checks, then you'd execute your unit tests, then you would execute your integration and your BDD test. And at this point, there's a potential here for doing some fairly simplified performance tests. And the web page test things fit in very well here. or some of the micro benchmarking, something like that. You can't, at this stage, you don't want to do anything that is too long because you want your feedback loop within seconds, minutes if not seconds really at this point. We get to the next step of looking to deploy things to a test platform with valid test data. At this point you can look at doing more kind of serious performance testing, and we can look at deploying real life versions of real life fully scaled up platform, firing up some injectors and firing some proper load at it, getting some scripts back out, some test results back out, and then praising them against some comparisons. And it's when you get to looking at the results that you get into some of the complexities of performance CI. But this sort of level, as far as I'm concerned, this can only really be done as part of a nightly build or an irregular build. It's not something you want to be doing on every check-in, because the overhead would just be too much and the time taken would be too long. And one of the things I wanted to mention just before is some of the challenges around actually getting a performance test within your CI. And one of the main challenges is, we were saying before, is getting something that you can get down to a binary result of pass or fail, which is obviously what you've got to get for a CI process. And it's so many variables involved in a performance test. You know, we're looking at sort of page response time, and then all the other kind of things, memory, CPU, you know, network usage, and trying to get something so that they're, you know, something where it's a pass and a fail on something that traditionally needs a little bit of human interpretation to look at. And that's something that we've been working quite a lot on within Intechnica, of trying to get that so we can automate results not only through a CI process but just from a general performance testing process, that we can take CIs and KPIs, give them a range of acceptable values, look at putting criticalities across multiple transactions, so some are important, some are not important. Every page probably has its own acceptable load time. It's very easy to look at a sort of CI process and put limits in place to say, yeah, all pages have got to load within 3 seconds. But you would not want to fail your build and not deploy it on the grounds that your About Us page takes 3.5 seconds to load. What you would if your home page is taking 3.5 seconds to load. So you've got to take all those things into consideration. You've got to look at, you know, what's acceptable, and then there's an area in between what's acceptable and what is not fit for purpose. So you would be aiming for 3 seconds, but 10 seconds, you know, at that point your page is not even good enough to go live. But there's a grey area in there where you may or may not accept it. And for all your CI process, you've got to think through all those so that you're not getting false positives for your developers every morning. They're going through trying to fix problems and they've got other things to finish. You've got to balance all those and get a realistic CI process. So I just wanted to finish my bit with a quick debate of why is this process so hard and why are so few people doing it? So, is it because the process problem? So people thinking we don't even know where to start with this process, or we don't know what we were just talking about with it's not binary. So how would we baseline it? How would we even test it? Or, you know, there's not frameworks out there for it. We don't even do performance testing yet. So why would we do CI? Why would we do performance? And the tests are brittle and they'll all be broken. We're continuously maintaining them. We're setting KPIs against things that we've not even done yet. Is that the main problem? Or is it just that there's not the tooling out there to do this yet? You know, you need tooling for CI, but none of the CI tools offer this sort of integration yet, and there's not particularly add-ons for them to do that. There's no tooling to empower this process and integrate APM results and benchmark comparison and all this sort of thing. The tools just aren't there. So, who thinks it's process? Who thinks it's tools?
Yeah, it's both.
Yeah. Is it just both? Right, so that's the end of my section. So yeah, all my contact details on there. So feel free to drop me an email or grab me afterwards if you want to ask any more questions about that. And then I will hand over to Mark, who's going to tell us what he's been doing and his team has been doing at Channel 4 to implement this process. So, Mark.
Okay. Yeah, I'm Mark Smith. I'm the online QA manager at Channel 4. If you're interested in Channel 4, you can find us on the telly. I first worked with Intechnica at ASOS, and they were the only company out there that shared my view that the last place you want to be doing performance testing is when you've written the application, because we've written, so many times I've been in situations where we've written ourselves into a corner and we do the performance testing and realise it's just not fit for purpose and we have to go back. I had a 3-month project once that we had to start from scratch because the fundamental architecture wasn't scalable. So, bit of an overlap with some of Andy's slides. Why continuous performance testing? Reiterating, it's at least as important as functionality on many sites, and I would start to say generally it's more important for the reason Andy said. You can lose your whole site quite easily for a performance issue. It takes a major functional issue to and performance breakages aren't necessarily code fixes, architectural issues. You know, you could have fundamentally designed your whole application in a manner that won't scale. So if that's happened, you need to know as early as possible. Build failures, short feedback loops. They can identify architectural failures early, and they can also stop code failures making it into the code base. And what we found when we started doing this, which we didn't think about, it wasn't one of the goals of it, but it's a massive reduction in the resources you need to do performance testing. As I'll show you in my example, you have a testing running automatically with no intervention, and you just get notified when you've got failures. You lose all that. Right, we've got to have 3 performance test runs in this sprint. We've got to schedule it. We've got to have someone running it. Suddenly, your projects start performance testing themselves. We never even considered that, and we're just seeing that now. Do you actually want pure CI performance testing? Now, there's fitting performance testing into the CI process with overnight performance test builds and executions, so you get regular feedback. But pure CI performance testing is actually fitting into your build process. Now that might be too disruptive during the early stages of the project. We see a lot of resistance to the idea that we should fail a build and not deploy because of a performance issue. Saying, well, all the unit tests have passed, so we can put it live and we'll sort it out later. But going back to previous points, a performance issue can be more difficult to solve, something that you want to keep out of your code base. It's more important to keep out of your code base than a functional issue. If you've got your project stable, and as early as possible, the earlier you can identify those issues, the better it is. So again, I say yes, you do, and you do it as soon as it's practical. And there's certain challenges. If you do this level of performance testing, each project needs to have the tooling. You can't just say, right, we've got a performance test tool and have a calendar and schedule it. You're constantly testing, so you have to have that tool available to every project all the time, which means your license costs are very high if you're using enterprise tools, because you have to have multiple controllers. It's not a question of the number of VU virtual users you've got. You need to actually have multiple controllers. So, obvious way is to go down an open source route. And that has issues as well. I mean, the main open source tool is JMeter, but that runs its injectors in JVMs. They don't scale very well. You can never really be sure, even if you do manage to scale it up, if your results are being affected by the capacity of the JVM you've got your injectors in. So you have to do a lot of extra work to actually make sure the results are actually accurately reflecting the performance of the application. So the requirements, if you want to do it properly, if you want to do it at the CI level, You need integration with the CI tool. You need the ability to failure build on percentile response rates, error rates, and other metrics at the transaction level, so you can actually build in your failure criteria, fail and build. You need front-end instrumentation, because in the olden days it was a question of putting load on the back end, seeing if that worked, and then assuming the UI would be fine. Now you've got sort of JavaScript and JSON and very sort of rich front ends. You could have a perfectly scalable architecture, and you could screw up your performance because the page is too heavy. It doesn't render. It takes 8 seconds to render the page on top of everything else. So this is become very, very important. It's not just load testing, it's performance testing. You have to actually know how your front end performs. And you have to collate your data from all your sources at the end. So you don't want to be sitting there working through your data to make a decision. You have to have your data collated and it will tell you what's happening. And if you want to go to the full volume testing, the overnight, building a as production environment to actually run full volume testing, so you can actually see how it will work in the real world. On top of that, you need to be able to scale to enterprise loads. So therefore, you need a viable injection infrastructure. And you will probably, even if you don't do this overnight, you will need to, when you find problems, you want to rerun that test, and you want to be able to monitor what's happening in real time. So you get an overnight failure, you look through the results, you can't figure out what's happening. You need to have real-time monitoring. So the tools we chose, this is actually slightly out of date because we've got more than this now, but we've built the bulk of it on Jenkins as our CI build management tool, JB to actually inject the load in your core, and web page test through the front-end instrumentation. And for the CI side, this is what we use, but for a lot of our performance testing, we use a tool that used to be called Facility Forecast, which is now Eggplant Performance. If you want to do really focused one-off load testing, because you've just got much better reporting and you can rely on the results much better. So we do use that as well. But for the CI, these are basically the tools we use. So this has been a journey for us, actually making what Andy's talking about into reality. We're not fully there yet. This is the first time I've done this presentation, and we've actually got some of it in place rather than reporting on progress of how far we've got. It's not that it takes that long to do, but if you don't get buy-in to do it as a project in its own right, you have to fit it as a background task and get there in increments. Where we are now is we're running overnight on a live project. We're building a full-scale environment with injection infrastructure. It's basically an as-live environment, running the tests, reporting the results back, tearing down the test infrastructure. And at the moment, we're playing with our pass-fail criteria. In an ideal world, you would have SLAs, you would set them at a certain level, and if you didn't reach those, you would fail. But we've got, as Andy alluded to the conversation we were having, we've got a program metadata library, which for our on-demand services, we get the information about the programs from there. We don't want to stub it out because it's part of our overall performance, but it's not in our team. And that's sort of showing peaks and troughs. It's not flat at the moment. So without that, to test our app, we have to set our fail criteria at the peaks, and then the bit above to take into account our application performance. Now, over the 2 hours that we run our test, we don't really have the problem that we might be running at a trough in their performance and up here, because over 2 hours, if we are not performing, we will hit one of their peaks at one time and it will fail, pretty guaranteed. But it means that we can't, in the environment we've got, actually have sort of black and white SLAs to pass and fail against. So, and what we're doing now, on top of that, is we're developing our short and sharp tests that we can run actually in the dev environment at a smaller scale, and every check in the CI build. We've realised we need to have background jobs to keep the environment warm, because as you probably understand when you're running a performance test, the first 15-20 minutes is warming the caches up and stuff like that. You can't do that in a CI build. You have to have the results really quickly because it's going to fail the build and stop everything going through. So we're creating the jobs now to keep that environment warm so that we can just drop the test in straight away. And we're targeting a test window of 5 minutes, but that will be negotiable project by project. There may be some projects where we can do it in 2 minutes. There may be some projects where we can do it in 15 minutes anyway. And at the next one of these talks, we'll probably have something to say about that and how we've got with that. And we've learned some lessons. You do need a relatively stable and consistent test environment because you are going to have to make those decisions about whether it's performing, and if the environment's all over the place, you won't necessarily know where your performance issues are. Your test might start failing for functional reasons. We also we realised we had to make the controller a slave to the build machine. Originally we put the controller on the build machine, but the overhead on the controller can affect the build. It may seem obvious, but if you're working on limited infrastructure, you may have no choice. But we're in EC2, so we had the option to do that, and we did that. You need a good reference build. What you can't do is compare against the last build. You can't say, well, okay, we've only decreased, we've got worse by 2 or 3% over the last build. We didn't get performance creep. So you actually need to have a reference build that you're confident about. You know the performance is right there, and you always compare against that. And you can change that if you significantly improve performance. You can have a new reference build. But you need to be comparing against a stable sort of reference. And it takes time, especially on the CI side, not necessarily so much on the overnight full production build. On the CI side, you need to take time to come up with what are the right pass and fail criteria. You can't map a low-level load test in a dev environment against what's happening in production. You have to have confidence in the code that you've got there, see what variations are acceptable as it feeds through, and use that to decide what your pass-fail criteria are. You don't want to be failing builds all the time unnecessarily, but you don't want the major performance issues getting through. And the CI tests are primarily trying to identify major breakages at checking. If we've got more subtle things, we'd get the overnight build to, we rely on those to pick those up. But your CI build, you're really looking for major breakages in performance. You don't have to wait till the front end is stable. You can start on the back end. The back end is generally there and working before you put the front end stuff there. So get your back end tests up and running, and then when you're confident your front end is stable, start building up front end tests. It's easier to start with the full volume test. It's more challenging to get it to work on the CI environment. So just get the overnight major big test running. You'll find a lot of your problems there, and you can feed what you've learned there into rolling out your CI build out of the bottom. If you are going to use CI builds, you need to keep your caches and your data raw so you can drop the testing straight away. So, what did we actually use to do it? As I said before, it's not just load, it's performance, and the front end is a potential minefield in terms of getting good responses and good performance. So we use web page tests to run full workflows on top of the back-end load tests. A lot of useful metrics. These are a few examples. Time to first byte, dump content, ready end. You can read those, I don't need to talk through all of those. And then we have Jenkins controlling the process. So everything is built around the Jenkins CI server. That triggers everything, runs everything. This could probably put another slide in there. First thing Jenkins does is trigger an EC2 environment build. We've done a snapshot of a production environment and the full injection and controller infrastructure.